Hey Genesis, so recently I got this comment to make a reaction video on animation versus math, which is a really famous math video out there on YouTube. So the first thing I did was taking permission from the channel owner, and I got it, with one condition that the content should be transformative in nature. So in this video I will also try to explain the math concepts which I see in animation versus math. Secondly, when this video came out I already saw it, but it was a while back, so today now I will watch it once again with you and also try to explain what's going on into the video. So let's begin. Okay, so here is the video, so let's start watching this video. Okay, so here's the stickman. This stickman is everywhere in his videos, so like, yeah, so here's one from where counting starts. So yeah, they start with addition basically. 1 plus 1 is 2. Okay, he can make as many ones. Okay. So like, one thing I would like to say, what I have observed, like law of conservation of mass or something doesn't hold. You can make as many ones as possible, like you can make in your mind. So yeah, they are just starting with addition right now. Okay, so yeah, 11, 12. Okay, oh, now he has a 2 as well. Okay, a 2, 14, 20. Okay, now he's adding bigger numbers. I think he wanted to reach till 100. Yeah, I remember this. Now what? There was something with iota. Oh, okay. Yeah, they just like merged, and 100 is equal to 100. Yeah, now what is it? Minus. Yeah, now like I think in this video they are progressing from like very basic things to like complex things. So first it was addition, like 1 plus 1, 2, like we do those on our fingers, and now we are like going to subtraction. Okay, 0. Yeah, 0. Like I would like to say one thing here, like now, so like 0 here popped out when we subtracted like 100 from 100, right? But 0 as of a concept is a very non-intuitive thing. If you like try to make math from scratch, 0 is kind of a counterintuitive thing to think about. That's why like Indian mathematician Aryabhat is credited with the invention of 0, like a number which represents nothing. Okay, something that represents nothing. So like here it just popped out like this. But yeah, if you don't know what number system is, the invention of 0 would be a really big thing if you like do it. Okay, so now let's move forward. Now till now we are at basic counting. Yeah, you can do mental math now. Okay, yeah, I remember this. There was some iota thing which popped out. So what happened here is that, okay, so this was -1, and then he did something. Okay, and it became this. Iota here is the imaginary number, which is equal to square root of -1. Okay, I don't know, from basic maths, like they have just jumped into complex analysis, and I think this is the whole point of this video. From what I remember, this e raised to I pi thing will try to run from him and he will try to catch it. So like, okay, so they just like show it at the start and they will try to like reach how to reach complex numbers. E raised to I pi is equal to -1 because this is the Euler's formula. E raised to I pi is basically cos pi plus iota sine pi. Cos pi is -1 and sine pi is 0, so this is why e raised to I pi is equal to -1. Like he poked -1 and it became e raised to I pi. Okay, now let's move forward. One thing I would say is like the sound design is really good. Sound design is very nice. Okay, he's trying to run. So like what happened is that e raised for I pi multiplied itself with iota, and it opened a new portal to some other dimension. It went to the imaginary space. Okay, so now after equal to there is nothing. Now it will try to catch it. Like that's the whole point. I don't know why, but okay, -1. Like you could like square root it. Okay, now he's trying to experiment with negatives. Negative times negative is positive. Like these small things that are here are like really foundational. So see, negatives time negative is positive. How would you like explain it to someone? Mostly people say like if you rotate something 2 times it will come back to its original point, right? So that is how we explain -1 times -1 is +1. So yeah, let's move forward. Okay, now we are going into some higher form of maths. Okay, I really like the way he's like representing division. Okay. Oh, I remember this a little bit, but I will just try to explain it a little bit. Okay, so what here happens is like first I will try to explain what he did with multiplication. Multiplication is just repeated addition, as simple as that, right? So that is cool, but how do you explain division to some 6-year-old, 5-year-old? So yeah, so this like you can show them this part. I really like how he made division minus division. So yeah, here. So see, 6, if you subtract 2 3 times from 6, it will reach 0, right? So 6 divided by 2 would be what? 3. Okay, like count how many times you subtract. That is division. Now divide by 0. How many times you can subtract? Oh, this is really good. Anything divided by 0 is infinity, like, so this is a really cool explanation to it. Why? Because how many times you can subtract 0 from 6? Infinite times, right? So yeah, really cool intuitive way to understand it. And the sound design, very good. It goes up, down. Okay, square. Now for the first time we see squares. Okay, so this is basically a plus b whole square, a square plus b square plus 2ab, and like they just represented it in some form of matrix. Yeah, repeated addition. Just square is multiplication is repeated addition. Like everything boils down to those addition and subtraction things. Okay, let's move forward. Subtraction. Okay. So like the law of powers, 4 raised to power 2 plus 1, basically 4 cube, 4 4 16, 16 4 is 64, but other way to do is like 4 square times 4, like the law of powers. So yeah, okay, let's move forward. He's like the same way he explained basic multiplication, he's trying to explain powers with adding more dimensions to numbers. Nice. I do remember some parts of the video. Okay. Yeah, this is also like many people don't understand why anything raised to power 0 is 1. So there are many different kinds of proof, but I don't know if there's like he showed one proof, like they are decreasing, like numbers are decreasing such a way. So like if you decrease once again, then it will become 0. Then a negative power will give you a fraction. Animation is too good. Yeah. And one thing I would like to say is things are happening so fast. I have to like stop it many times. Okay, so now they have reached till square roots, which is good if you want to go till iota. Okay, root 2 is irrational. Okay, now he has found iota, which is the key to finding e raised to power I pi, I guess. Okay, he found that. So basically iota times iota is iota square is -1, so square root of -1 square is -1, and multiply by I is basically this thing is -1. So yeah, he just like derived this into existence back. Okay, he threw it. Oh, what happened was it tried to multiply itself with I once again to vanish, but then he multiplied it again with I by throwing I to from imaginary come back to the real space. Okay. Oh, you right now you can also see this in this split second. It to push it also like showed its real form. Yeah, this cos pi plus iota sine pi, and minus is there. Why? Because okay, minus was already there. E raised for I pi is cos pi plus iota pi. Okay, so yeah, it's running. Yeah. Oh, with man, these there are so many Easter eggs. Okay, so like if you have noticed, when this minus hit him, he like flipped. Look. This, so like it's just reversed minus. Oh, nice way to so here you can see see it was e raised for I pi, so it was here. Like if you imagine a circle going from 0, 90, pi, 180, then it subtracted pi and it had to go to 0. Nice way to escape. One thing I don't know, why is he chasing him and why is he running? That I have no idea. If you guys know, comment, because I have no idea why they are chasing each other. Okay, use some. They make guns in this video, I remember. They make guns. Oh, multiply. So I also like this. He was chasing him and he multiplied himself with to run faster. Accelerate. Multiply with minus. So I won't explain a lot now, so that we can complete this video in some. I don't want this video to be very long. So they made swords. They will make guns also. Oh, again that rotation thing. He has a bow now. Oh, this is a 2, I guess. This is a 2 and he is shooting 4s. Iota. Oh. So what just happened is that with multiplying itself to iotas, there is a real line and imaginary space is imaginary axis is like in the y-axis. So if you multiply it by I, he went to the y-axis. Great. Whoever made this is like really cool. Okay, now what he will do with this dot? Okay, so this is letting him go into the imaginary axis. Okay, he made the unit circle imaginary. See, you can look at it. This is the real number line and this is the imaginary space, and you can represent like imaginary numbers are really well represented with rotations, and circular multiplication by I is like a rotation by 90 degree. There is a subject called geometric algebra which uses this and explain this in a really great way. Okay, you can look at it. He's experimenting with stuff. I won't go in much detail, like too much detail would be like too much. These whole concept, these simple concepts will take whole hour of videos. Okay, so now he's like r times theta is what, if you know, you can comment right now. it's the arc length. Okay, yeah. So like when he pushed this circle, this is the imaginary space, like real line is just the part of it. Now I think he will experiment with rotation and things. Can't do anything to theta. Okay, just changing theta. Okay, if we change this push, the radius changes. Okay, I don't know what it's trying to do now. Okay, he's pi to cos theta and sin theta. Okay. Oh, okay. Here what is happening is that you can like explain rotation, uniform rotation, with sine and cos waves. Like this, whatever this dot is tracing in y-axis is the sine wave, right? And whatever this is on the x-axis is the cos wave. Okay. And then it like both this tongue is very nice sound. Okay, multiplying it. Oh, okay. So this explains that multiplication with iota is a rotation by 90 degrees. So we multiplied sine wave with 90 degrees. So it like went up. Now these are this basically is the graph of sine wave and cos wave together plotted. Oh, okay. What just happened? Okay, cos plus iota sine, that will just pop out. Oh, found him. Now I remember they make guns at some point. Okay, he has his bow with him. Okay, wait. Here what happened is that so this is basically the series expansion of exponential number. Okay, so here e raised to power x here should be x, but it is I pi because it is e raised to power I pi. Okay, now what's it shooting? Oh, when it's hitting I want to see what kinds of. Okay, oh my god, this is really cool. So one thing which I'm like right now noticing is that one thing I noticed that when it's shooting these numbers are increasing. So 9 when it shoots once again, 10, and when these bullets are hitting, this is the value of that part of the series. Okay, so very nice Easter egg. So many Easter egg. I might be missing many of them. I don't know. See, this is increasing. Oh, this was a cool move by him. So let's look at it once again. So he multiplied it this like just a circle multiplied by 8 would increase its, give it a new axis and will become a cylinder. Okay, now what is the plan? Doing something going into the imaginary axis. Okay. Oh, pulling it into his own regime. Oh, nice. What he did was I did multiplied it by negative. This is a really cool trick here. It's a really fun video. A gun, cosine gun. Okay. I will need to explain this a little bit. Okay, this is cos pi plus iota sine pi. This is basically the imaginary number representation of cos theta and sine theta. Like if you put cos theta and sine theta in here, like e raised to power I pi and e raised to power minus I pi, the Euler formula cos theta plus iota sine theta, then you will get that thing back. This is just a way to represent them. Somewhere it is very useful. Like this exponential things are very easy to handle in maths. That's why a lot of people use this. Okay, like again, it's multiplying. One thing, whatever space is this, whatever universe is this, in math I think you can generate numbers from anywhere. Like law of conservation of mass or anything doesn't hold. So like they are just changing forms and increasing in mass. Okay, a tangent gun. Okay, you know that, right? Sine theta upon cos theta is tan theta. So this is just the tan function. Okay. Okay, like if you look closely, these are tan functions. Okay, they are chasing him. I don't know why they are chasing him. No idea. Okay, okay, they are like moving in the imaginary axis. Multiplied it by pi, so it will go to the other side. So many. I don't think this gun is enough. He will make a bigger gun. He will go till pi. Okay, he found infinity, I think. Oh, the infinite gun. I think dividing by infinity everything. What just happened? Okay, going back there. Changing forms. This is really cool. I would like just explain it now. A monster, Irishwar iPi monster. So one thing I would say, everything in here is simply I think a representation of Irishwar iPi. And what just happened is that I think he threw infinity and there was something he was holding and it made that into an integral. So this is the sign of an integral. Okay, alright, and I think these are the integrals and their solutions are these. I think, I don't know, I would need to solve these, but I think these are those integrals and these are their solutions, and they are all I think exponential. Okay, the final showdown. I really like wherever this integral is going, there's some kind of graph. Nine iota means 9 times up. Okay, he's going up. Now he's going to shoot a really big blast. The tan gun. Yeah. And it's gonna die now. Oh, okay, now this is the biggest blast. Okay. Oh my god, is this a black hole or something? It's trying to run. Oh my god, I don't think he will. Right now the animation is too good. Trying to catch it. Yeah. He went into the imaginary realm. Okay. Oh, it was basically the bottom. Okay. Broke the fabric of space-time. Imaginary number. These are all imaginary numbers. Trying to save it. Okay. So he will save him and okay. The imaginary so one thing I know now is that imaginary space is destroyed. Now he is like telling it something. Okay, they become friends basically. He's telling him to like help him get out of this place. Okay. just multiplication by iota. Okay. I think he will create a portal somehow. Or doing something. This is the gamma function. A way to represent factorial. Okay. Then I think he is doing something to teleport it. Him to somewhere. Okay, bye bye. Okay. Teleportation complete. Phi delta. This is a really big symbol. I don't know much, but this is somehow helps represent infinities. Some way to represent them. So now I think they are going to live a happy life now. Oh yeah, this I think. Yeah, the end. So yeah. So this was my reaction on animation versus math. So if you like this video, do comment. I can make a reaction video on animation versus physics as well, since I myself am an astrophysicist, so I would be able to explain those things a little better also. Also, thanks to all the channel members for joining channel memberships, and thanks for watching this video, and always remember that math is everything.